All right, guys. Well, welcome to one of my first video lessons. We'll see how it goes. I'm not a professional. I mean, you gotta work with me, guys. Show some mercy. I'm speaking to an empty classroom. I gotta work the camera. I don't even know if I got the right angle. I'm hoping the lighting's good. I'm just hoping this will help you guys understand chemistry a little better rather than just being on your own, of course. Well, you guys, at this point where you guys are watching, you probably got about 5 days down. Only about 175 to go. That shouldn't. Hopefully that doesn't bum you out. Guy says, I don't know. He's looking in the mirror. He said, do my sideburns look even? He's speaking to his dog. He said, yeah, but your face is crooked. That's kind of messed up. Okay. Moving on. So you guys, today's lesson's about metrics. Oh, you know what? Before that though, because, you know, maybe metrics, you guys, because remember, chemistry is the study of matter, and in order to really study matter, you got to be able to measure, you got to have units, and we tend to use metric units. You guys have been introduced to this in middle school. But, you know what, I kind of want to do something else. I like doing some demonstrations. You guys remember, chemistry is the study of matter, and it's, you guys remember, and it changes, so we want to see one of those, so I'll just put this on hiatus here briefly. So I just want you guys to see some things. Got to always be safe. Here, you guys, I have a penny. I don't even know where you guys are at. Where you see that penny? Okay, so we've got a penny. And then I also have here, so think about penny, and you can use different properties to describe it. You could say it's like a brownish, you know, a brownish solid. And then we have here, we have what's called nitric acid. You guys are familiar with a penny, maybe not so much with nitric acid, but if you had to describe nitric acid, you say, oh, it looks like a clear liquid. Okay, that could be good. Now check this out, guys, and there's a reason why I have my goggles on. Careful with that. I don't know if you guys can see, it's probably hard to see, but there's actually fumes coming out of it. This thing's so concentrated over your nose hairs, so I gotta be really careful with that. So anyways, I'm gonna place a penny in the flask here, okay? And then I'm going to bring the nitric acid in contact with that penny, okay? And then we'll just make some observations. That's what science is all about. You gotta be awake, you gotta be making some observations, so we'll do that. Okay, so observe what's happening. Don't see anything yet. And you guys should be making some. I don't know if you guys can see that. See that orange like material coming out of that. Now you guys, this is actually pretty noxious and it will kill me. So in order so I don't die, I'm gonna have to move this to my fume hood. Unfortunately, that's outside the camera. Move it to the fume hood. Can you guys hear that noise in the background? That's the fume hood. A fume hood's this thing, and when we do come back, you guys are gonna see it, and it sucks all the air up and any kind of toxic, noxious things, and get it out of the classroom. So I wanted to show you guys, so now that's just kind of going, and it's kind of crazy right now. Unfortunately, yeah, you can't see everything. But you guys kind of saw what was happening. You guys saw some changes. That was an indication, right? Chemical reaction was occurring. And now here's what we end up with. Now check it out. So this I had done before, right? Okay, so this is, after that is all done, this is what we end up with. Now you guys can look at it. You guys probably describe it, you're like, yeah, it looks like a blue liquid. I would imagine if you're even halfway awake, you have a question at this point. You guys, what kind of question would you have? What would be a question you might have? Well, guys, are you gonna answer it? Oh yeah, I can't answer it, of course. There's nobody here. Where is the penny? What happened to the penny? You guys remember there's a penny in there? Remember there was a penny and there was a clear liquid? Now all I have is this blue liquid. You remember there was this orangish kind of gas coming off. The question is, where did that penny go? You guys, I'm going to leave that as a question because this might be a question that we might come back to, and I might solicit responses from you guys later. But part of science is making observations and then really thinking about, okay, what happened there, and see if what we come up with fits the phenomena that we observe. Okay, so that would be a, you know, kind of a typical chemical reaction. Okay, so, you know, just to let you guys know, that's what chemistry is about. But in order to be able to measure these things, we do have to learn some things like the metric system and so forth. So sometimes we need to measure the length of the distance of matter, of stuff, right? So the question is, what is the basic metric unit for length or distance? You guys know it. It starts with an M. It's the meter. And you guys should know a meter. Whenever you guys think of a meter, just think about this meter stick in front of Mr. Wilson, on Mr. Wilson's board. This is a meter, okay? But there can be other things. Maybe we don't want to use a meter if we're talking about, maybe really small things or really large things. Here are some other things. Oh, by the way, guys, so you guys, if it's really big font, that might be something that I want you guys to take, notes on, right? You guys remember, I'm going to expect you guys to take some notes. I'm not going to tell you how many notes. Do you have to write everything? Not necessarily. I'm not going to be looking at every individual word, but just you're demonstrating to me that you are following along. And you guys, if you think about it, if you already know something, then there's really no reason to take notes on that. What you take notes on are something that you think is important and that there might be a tendency for you to forget, and so therefore you write it down so when you can look back at it later, you can recollect what you had learned previously. So we have KM. You guys know what that stands for. That's kilometer, and what a kilometer is, that's 1,000 meters, right? So if we're talking a long distance from here to the stadium, for example, we might want to measure in kilometers. Meters, this would be like a perfect measurement if we were doing, dimensions of a classroom. Centimeters, you guys, here's a centimeter. Centi, if you think about cent, what do you think about? You think about like pennies, a cent. How many pennies in a dollar? If the basic monetary unit in the US is $1, a cent, how many cents in a dollar? 100. That's where we get that word cent means, because a centimeter is this measure right here. Then you guys can probably guess, well, how many of these little centimeters are there in a whole meter? 100. Just like there's 100 cents in a dollar, there's 100 centimeters in 1 meter. And then lastly is a millimeter. Those are the little guys. And that is, I know you can't really see it, but it's the little lines on this meter stick. I don't know if that threw you off. And you guys might be able to guess how many of those little itty bitty millimeters are there in a meter. If there's 100 centimeters, you guessed it right, there's 1,000. So a milli means 1,000. Okay. Well, we also have to measure other things, like the volume. You guys, volume is kind of the fancy word for space. How much space does something take up? Does anyone know the basic metric unit for volume? Okay, you are correct. It is a liter, okay? And you guys, a liter, you guys are probably familiar. You guys always want to relate it with things that you guys are familiar with. What are you guys familiar with? 2-liter bottles of soda. So you guys already have some understanding of, the metric system to some measure. And a liter came from, when they were developing these standard units, it came from the measurement of length or distance. A liter was defined as a space that's 10 centimeters by 10 centimeters by 10 centimeters. Because if you guys think about it, there's 3 components, because volume has 3 components. It's got a, what do we got? We've got a length, right? We've got a width, and we've got a depth, 3 components. So here is a liter. So here's how a liter is defined. This is a liter. This is 10 centimeters by 10 centimeters by 10 centimeters, and that's what makes up a liter. Okay. And if you guys multiply this out, you guys can do this. You guys math whizzes. What's 10 times 10? 100 times 10 is 1,000. That would be 1,000 centimeters cubed. You see how you also have to do that with the units. You guys remember from your math class, you also have to multiply the unit. And you guys see why it's to the third, because it's got 3 dimensions. It's got a length, a width, and a depth. And that, so when they say 1,000 centimeters cubed, just look at this, check this out. I can plug, like this is like the mama cube, check it out. Oh, she just gave birth to a baby cube. Oh, cute. So, this is 1 centimeter cubed. It's 1 centimeter by 1 centimeter by 1 centimeter. When you think about it, how many of those, you could call a cubic centimeter, how many of those centimeter cubes make up 1 liter? You guessed it, 1,000. So if I could break mama up, she'd be producing 1,000 little babies. She's kind of busy. Okay. And then here's some just different ways to say the same thing. So we talked about 1 centimeter cubed. That's this little buddy right here. Okay. 1 centimeter cubed. We also call that 1 milliliter. Milli. Remember milli from up here meant 1,000. So it's 1,000th of a liter. And then we can also call it a cc. Maybe you guys have heard of cc. You heard somebody like riding motorcycles and they have like a 50 cc engine. That's giving you the volume of the engine. Or maybe you watch like a medical show and they said, nurses running in because there was somebody who got a gunshot from a gang shooting or something like that. She said, hey, we need 10 cc's of blood or something. What's she talking about? Cc is just cubic centimeter. Cubic centimeter, which is the same thing as a centimeter cubed. It's just a different way to say the same thing. Okay, so these are different ways to talk about. Oh, we talked about. So here are the main ones we had are milliliter and liter. Those are the 2 we talk about primarily when we're talking about volume. So here they are right here. They're abbreviated, right? We don't want to write out liter all the time. We write big L. Milliliter is little m, big L, milliliter. Once again, there's 1,000 of those in there. Okay. And lastly, we also want it when we're talking about matter, not only will we talk about the length or the distance of it or the volume of it, but we also want to talk about the mass or the weight. Those aren't necessarily the same thing. Weight is affected by gravity, but mass is how much matter is there, okay? But we're going to use those interchangeably. Does anyone know the basic metric unit for mass or weight? Don't say ounces, silly, because that is the English unit. That's not the metric unit. What's the metric unit? Starts with a G. You got it correctly. It is a gram. You're like, a gram? Well, how much is a gram? If I ask you, hey, is a gram a lot or a little? What are you going to say? What do you guys think? A gram? A lot or a little? Yeah, it's a little. You know what, just to help you guys out, you know what a gram weighs? If you just think about a paper clip, you guys, we're all familiar with paper clips. That weighs about a gram. But let me ask you guys, scientists back in the day, let's say 100, 200 years ago when they were coming up with these basic metric units, do you think a bunch of scientists were kind of sitting around the table and they're like, you know, what are we going to make as our standard metric unit? We'll call it a gram, but how much will we say a gram is? Do you think one of the scientists 200 years ago broke out a paper clip and said, you guys, I got it. Whatever this weighs, we're going to call that a gram? No, silly. They didn't have paper clips 200 years ago. No, they used something a little bit more ubiquitous. Guys, that's a big word for you, ubiquitous. You know what ubiquitous is? Fancy word for common. Can you guys tell me what's a common, something common? You can't tell me because I can't hear you. You're probably saying something, but I can't hear you. But I want you to think about something that's really common that chemists might use as kind of a standard piece of standard sample of matter to use for measurement purposes. Anyone think of something ubiquitous? It's super common. You guessed it. It's water. It's water. So here's how they define what a gram is. They said a gram is whatever. You guys remember how much a milliliter is? It's this little bit here. So if I had this much water, whatever that weighed, they said, you know what? We're going to call that a gram. And that's how we got a gram. So you can see how all of these different metric units are all intertwined with each other. Okay, so now the main emphasis of this lesson, you guys, is being able to convert between the various metric units, because when we talk about matter, we have to indicate how much of it we have. So we have to be able to use the proper units and know how to convert. Here are the, before we do that, here are the ones that we use primarily. You guys can imagine, what do you guys think mg stands for? That's milligram. That's just a little bit. And then G is gram, and then you guys could probably guess kg. That would be, why am I still wearing these? I was wondering why. COVID, that's what it is. Kilogram, kg is kilogram. Okay, so now I'm going to have you guys, now there's going to be a chart that I'm going to have you guys copy. And you guys, I'm not going to leave it up there too long, because you guys can always, sorry, that few moves down. You guys can always, right, you guys can always stop the video, right? So I don't have to wait. But you guys, here are all of the prefixes that we would use with the basic metric units. You guys remember the basic metric units are M for meter, that's when we're dealing with length or distance, L for liter when we're dealing with volume, and G for gram when we're dealing with mass or weight. And what we can do is we can add any one of these prefixes. So you guys, I do want you guys to copy this chart. We can use any one of these prefixes and place it in front to change the value of whatever it is we're measuring. So some of you guys, to help you guys to remember this, because the thing is, you can copy this down and we can see, what does kilo mean? When you put kilo in front of something, it means 1,000. What does, for example, centi means? It means, you guys know what 0.01 is? That's 100th. You guys remember we talked about that, 100 cents in a dollar. So it's 100th of the basic unit. You guys might have learned some dumb hokey phrase back in middle school to help you guys know the order, because if you can know the order, if you memorize the order of these, you guys are going to be able to convert. Some of you guys have different ways in which you guys are able to convert between metric units. I would say, I'm going to say my way is the best way, because you guys follow me here. Check this out. Look how this works. And some of you guys might have even learned this. Dumb hokey phrase. You guys think about it. K. Because you guys remember, if the dumber and the hokier the phrase is, the more inclined you are to remember it. So we got kilo. If we could just remember king. H, Henry. Guys, I think the England had like a bunch of King Henrys. I can't remember which ones. King Henry D for Deca, died. So what it's doing is, you guys see how this corresponds to the first letter of the prefix. On unit, that's called a base unit. You guys will call this, you guys put that. It's called a base unit. This is what you add all the prefixes to. And so I'll say that'll be B. I'm going to say King Henry died by, I get Deci, drinking. C for centi corresponds to chocolate. And milli, M, or milk. Now you guys see, this would be hard to memorize, but if you just remembered this dumb hokey phrase, King Henry died by drinking chocolate milk, you're going to be more inclined to be able to do conversions. Now just realize, guys, all these prefixes, you notice how they differ? They all differ by a factor of what? By 1 factor of 10. And the nice thing about the metric system, it's based on factors of 10, and each factor of 10 corresponds to 1 decimal place. So we're going to show you guys, just by knowing this, how you guys can make some conversions. Okay. Okay, guys, we're gonna practice. Okay, so we're gonna practice. Let's see here. I think we can. Trying to think of how we could. Yeah. Well, I think you guys can see it. Okay, so here's how it works. Okay. So the first thing is you look at what unit you're starting with. Okay. So now we need to convert. We've got half a meter, 0.5 meters, and we want to convert it to centimeters. Let's say centimeters is a preferable unit for whatever we want to measure. Okay. So we look at what unit we're starting with, and we go with M. And so you might be looking at, and so all you need to do is use your phrase. But we got to. Here's what you guys got to remember. M is what you call a base unit. Okay. So M is a base unit. So what we're doing is we're starting at by. You guys see that? So we're looking at the unit we're starting with, and then we look at the unit to which we're going. We want to convert it to centimeter. Well, that's a centimeter. What in our dumb hokey phrase corresponds to centi? You got it correct. That is chocolate. And now you guys look and you see, remember, each one of these differs by a factor of 10. So how many factors of 10 does it take to go from by to chocolate? Once again, you guessed correctly, 2. You guys, this is the beauty of it. What that tells us is we need to move our decimal place 2 spaces, because each time you move a decimal place, it corresponds to 1 factor of 10. So we see where the decimal is right here. Now I got to move it 2 places. Obviously, what's the last question we got to ask, though? Which way are we going to move it? So here's how it works, guys. In order to determine that, you look at what happens to the unit. And you got to see, is the unit getting bigger or smaller? I'm going from meter, which is my base unit, to chocolate. You guys think about it. I'm going from a meter to a centimeter. The unit's getting what, guys? Smaller. If the unit gets smaller, in order for this equal sign to be held true, if this gets smaller, the number has to get bigger. So then I would ask you at this point, which way would you move the decimal point in order to get the number bigger? You guessed correctly again. You're going to move it to the right. And how many places do we say? 2. So I move it 1, 2. So here's where my decimal place would go. Well, you guys, what am I going to put in that trough right there? You guessed correctly. I'm going to put a 0. So what now is my value? It's 50 centimeters. And if you guys think about it, it makes sense, right? Where's my, here it is. Guys, look, 0.5 meters, isn't 0.5 just half a meter? Here's half a meter. Well, how many centimeters is half a meter? If you guys can look at that, it is 50 centimeters, okay? Now, you guys, this might be the first time for some of you, so we're going to do a few of them, okay? So here's the next one. Okay, now this, I'm hoping that this doesn't confuse you. We've got 800 millimeters, so write that down. We want to convert that to kilometers, okay? So once again, you guys, all we have to do is use our dumb, hokey phrase, okay? So, you guys remember how it works. We look at our units. We're going to analyze the units. We're starting at millimeter. You guys, where is the millimeter? What corresponds to millimeter? What corresponds to milli? You guessed correctly. That is milk. Okay? Now we're converting that to kilometers. What refers to kilo in our dumb hokey phrase? Yes, it is king. And you guys remember what you do is you're like, okay, how many factors of 10 difference is there between milk and king? So then you just count. 1, 2, 3, 4, 5, 6. What does that tell us? We're going to move the decimal 6 places. I don't know where the decimal is. Don't you fear, the decimal is always at the end. So the decimal's right here. I got to move it 6 places. Once again, what's that last question we got to answer? Which way do we move it? So once again, you guys remember what you need to do? You look at the unit, see what happens to the unit. Is the unit getting bigger or smaller? Think about it, guys. I'm going from millimeter to kilometer. The unit's getting bigger. We're going from a small unit to a larger unit. It's getting bigger. So if this is going to be true, if the unit gets bigger, the number has to get smaller. So which way do I got to move the decimal point, guys? How's 800 going to be smaller if I move it to the left? 1, 2, 3, 4, 5, 6. So I put my decimal at the end of that. You guys remember what you put in each of these troughs, each of those little dips? You put zeros. So what's my answer? It's 0.0008. And you guys, a lot of times, in order to draw attention to the decimal, they'll put a 0 here. You see that doesn't affect the value that you have there. But all right, try another one. No, it would actually be good if you like stopped the video right now and you guys just practiced on your own rather than waiting for me to do it, because that's how you train. But either way, you guys are going to be doing it on your on the assignment that corresponds to this lesson. 0.2 grams. Okay. Once again, you guys, I know I'm going fast for some of you, and that's intentional because I know you can always stop the video. And for some, maybe I'm going too slow, and so I'm trying to find a happy medium here. Okay, so I'm looking. You guys remember, you have to first see where you're at. Now look, I'm starting with gram, and you're looking here, you're like, man, I don't see any G, but what do we have to remember, guys? Oh yeah, gram, that's a base unit. You remember that's a base unit for mass or weight. So I'm going to start at my bi, because that corresponds to the base unit, and then I'm going to milligram. And you remember milli is milk. How many factors of 10 difference? 1, 2, 3. So I'm going to move the decimal 3 places. I just need to know which way. I look at my unit. Is my unit getting bigger or smaller? I'm going from gram to milligram. The unit's getting smaller, therefore the number has to get bigger. How am I going to get this number bigger, guys? By moving the decimal to the, you guessed it, to the right. Okay, and I'm going to move it 3 places. 1, 2, 3. Put my decimal there. I fill in zeros in both of these dips. So 0.2 grams is equivalent to 200 milligrams. You guys think about it. Where do you guys hear milligrams? You guys know where you hear milligrams? Probably the only place I would think you would normally see it is if you read your like medicine bottles, right, or your vitamins, and it's going to be in milligrams because it's going to be very small doses. And so you'd think it would be a lot better if on a label, rather than them putting, oh, there's 0.2 grams of vitamin C, right? Wouldn't it sound better to say it's 200 milligrams of vitamin C? So that might be a reason why they would choose milligrams over grams, even though 0.2 grams here is the same mass or weight as 200 milligrams. It's just a different way to say the same thing. Okay, here's the last one, guys. Stick with me. 80 centimeters cubed is equal to how many milliliters? I'll remind you guys, centimeter cubed, you're like, you know what? This is kind of a trick question. Remember, this is a centimeter cubed. If I have 80 of those, how many milliliters do I have? Anyone? Anyone? You guessed it. We have 80 milliliters. You guys just remember, centimeter cubed is just is the same thing as a milliliter. They're both the same thing, just different ways to say the same thing. So 80 is 80. Okay, guys, so that is our lesson, and we will see you guys next time.